everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about verifying trigonometric identities. Ooh, yeah, that's an immediate sort of heart in the throat, like, that's a crazy sounding sort of thing. When we talk about verifying trigonometric identities, here's some basic trigonometric identities. These are things like saying that the cosecant, let's make this a thicker line so you can see that better, that the cosecant, and I can't write the letter S, cosecant of x is equal to 1 over the sine of x. That is a trigonometric identity. Saying that tangent of x equals sine of x divided by cosine of x. That's a trigonometric identity. Saying that sine squared of x plus cosine squared of x equals 1. That's a trigonometric identity. And there's quite a few of these, frankly. The ones with the squares are your Pythagorean identities because they all come off of the Pythagorean triangle. Now, proving that these are true, like sine squared plus cosine squared equals 1, that's not what this video is. What this video is using things like that, which you should be given a list of the fundamental identities, is using them to prove other things, to either simplify things or to prove other things, to verify other more complex identities. So here's an example. Let's say we're given that cosecant of x plus cotangent of x squared. I always write so big. I always write too big. I'm aware of this. I know this. So why don't I start? And I also, it should be in the center. No, it shouldn't, whiteboard. You don't tell me what to do. Is equal to 1 plus the cosine of x over 1 minus the cosine of x. Now they're telling you this is an identity. This is true. Prove it. That's what verify means, is prove it. When you're presented with one of these, a couple of things that are sort of strategies. These are very much puzzles. It is a problem-solving puzzle situation. So there's a couple of steps to help you find the key to the puzzle. First one is you don't have to work on both sides of this equation. You don't. You're basically trying to take one side and make it match the other side. There may be exceptions to that, but that's generally, if there are, I can't think of any right off, is you pick a side and I'm trying to make it match the other side. Usually start with the more complicated side and say, I want to make it simpler to match this side. So I don't really have to do anything with this. I can kind of ignore it for a little bit. I keep in mind that that's my goal, but all of my manipulations and everything I'm doing to the left side. This isn't like in algebra where I need to multiply by 2 on the left. I need to multiply by 2 on the right. That's not what this problem is about. It is about changing this through various steps and using various previously proved and verified identities, changing it into that. The other big thing, which I recommend doing immediately, some books would have you do things like, first let's square this and let's, square that and work it out and then do stuff. I don't like starting there. Start with changing everything into terms of sine and cosine. And you can do this. Everything can be changed into sine and cosine. What do I mean when I say everything? Well, what is cosecant? 1 over sine. All right. What is secant? 1 over cosine. Almost wrote sine again. 1 over cosine. What is tangent? Tangent is sine over cosine. What is cotangent? Cosine over sine. You can change everything into terms of sine and cosine. This will help you out immensely. So that's where we're going to go. I'm going to scoot this over so I'm not really looking at that anymore. I'm just looking at this. Cosecant x plus cotangent x squared. All right, what is cosecant x in terms of sine? 1 over sine of x. Okay. What is cotangent x in terms of sine and or cosine? It is cosine of x over sine of x. All of this is squared. Now, sometimes some books will do something like saying, oh, this is where we need to do a plus b squared. So that's a squared plus 2ab plus b squared. And I need to multiply this out. Nope, that's not, I think, the best way forward. Here's what I think is the best way forward. Look at this and look, they have the same denominator. You can add them. So I'm going to add them. 1 plus cosine of x all over sine of x. I just added the numerators. And that is squared. Well, what does that mean to square it? It just means I'm multiplying that times over sine of x. Now, I'm not going to distribute this, and you'll see why in a second. Okay, so on top now, I'm just going to leave them as they are. Just going to leave it as 1 plus cosine of x times 1 plus cosine of x. Now on the bottom, sine of x times sine of x is sine squared of x. Why did I leave it like this on top on the numerator and not, multiply it in? Is because, remember, this is my goal. This is what I have to have in the back of my mind. I'm working towards 1 plus cosine of x over 1 minus cosine of x. And I've got a 1 plus cosine of x up there. I'm going to leave it because I'm thinking that could be helpful. All right, so what do I do next? Next, I'm going to look at my identities and say, okay, I'm needing to get to cosine. So is there any way that can relate sine squared to cosine to cosine? Well, there is. That's one of our Pythagorean identities that says sine squared of x plus cosine squared of x equals 1. So if I subtract cosine squared of x from both sides, I get that sine squared of x equals 1 minus cosine squared of x. Okay, so that's what I'm going to do. I'm going to replace this sine squared x with 1 minus cosine squared x. Okay, so over here, I've still got my 1 plus cosine x times 1 plus cosine x on top. But now on the bottom, I've got my 1 minus cosine squared of x. Now the one thing that is from algebra that you need to remember for this is that you need to remember what a difference of squares is. Difference of squares says this: if I have a squared minus b squared, I can factor that as a plus b times a minus b. It's just an easy way to factor things. So that's the one sort of aha moment that needs to happen in this. 1 is a square. 1 squared is 1. Cosine squared is a square. Cosine times cosine. So this is a difference of squares, a square minus a square. So that can be factored as is seen right here, a plus b, a minus b. All right, so we're in the home stretch. I've still got my 1 plus cosine x times 1 plus cosine x, running out of room, on top. And on the bottom, 1 plus cosine x times 1 minus cosine x. Oh my goodness, we're so close. Look at this. Wow, my handwriting's getting so terrible. Okay, because I factored it. I used this rule over here and I factored it. And now, because there's the thing in math where, let's say if I have like 5 times 2 over 5 times 3, I'm multiplying. I've got a 5 and a 5. I can cancel them out. We can do here, I'm multiplying 1 plus cosine of x on top, 1 plus cosine x on the bottom. I am left with 1 plus cosine of x all over 1 minus cosine of x. Ta-da! And I have verified that identity. So again, just our little highlights here. First things to do, start with the more complicated side and try to change it into the less complicated side. Take everything in it, change it into terms of sine and cosine. Don't multiply unless you have to, unless you think it will help. Keep things separate because you never know, you might be able to cancel them. If you're not getting anywhere, then start combining. Whenever you see a sine squared or cosine squared, etc., think of Pythagorean identities and how you can move it around to exchange it if that will help you. And big one here, the sort of algebra popping in, is look for things like perfect squares and difference of squares. Just as a little reminder, a perfect square is this format, and it's when you take a plus b and you square it. You get a squared plus 2 times a times b plus b squared. Those two patterns, the difference of squares and perfect squares, tend to show up a lot in these trig identities. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.